My name is Arfan Raimee. We from group number 1 want to explain about chi-square test. Let's begin with the case study number 1. For this study, we are investigating whether there is a difference in age distribution proportion over the time using the chi-square test for the goodness of fit. In 2015, US, Texas, the age distribution in small town was recorded as 30% less than 18 years old, 40% age between 18 until 35 years old, and 30% greater than 35 years old. So in 2020, a local government organization conduct a random survey of 1,600 individuals from the same town. They observe the result. From the survey were 121 individual age less than 18 and 288 individual age between 18 until 35 years old, and last survey is 91 individual age greater than 35. So the main objective of this study to determine whether the age distribution in 2020 is significantly different from population proportion record in 2015. So we go to question number 1. The key question we want to answer is there significant difference between the proportion of individual in each group in 2020 sample compared to the 2015 population? So to assess this, the operation statistical method in the chi-square goodness of fit test, which compare observed frequency with expectation frequency. So step number 1 in the test, in this test is to calculate the expectation with frequency by convert the 2050 percentage into actual number based on the sample size of 600. So we're using formula. Expected frequency equal to population and percentage times sample size. So we can see this based on the data we collect, less than 18 years old, 13 times 600 divide 10, we got 118, and 18 until 35 years old, 14 times 600 divide 100, we got equal to 214, and greater than 35, 13 times 16 divide 100 equal to 118. So I pass the next slide I pass to the next slide to the next presenter. Okay, that's all for me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nazaudi bin Aziz. I will presenting about the chi-square statistic goodness of fit test. I will continue on the step number 2, which is we need to set up the hypothesis. Hypothesis we have 2, which is the first one, null hypothesis, H note. There is no significant difference in the age distribution of the sample in 2020 compared to the population distribution in 2015. For the second hypothesis, which is the alternative hypothesis, H1, there is a significant difference in the age distribution of the sample in 2020 compared to the population distribution in 2015. Let's begin with the step number 3, which is to introduce the formula given. The formula to calculate the chi-square statistic, which is the x power of 2 equals to the sum of observed frequency minus with expected frequency, power of 2, divided by expected frequency. For the step number 4, which is to calculating the chi-square statistic, we need to apply and implement the data into the formula given. By 200 minus 180 power of 2 divided by 180 plus 250 minus 240 power of 2 divided by 240 plus 150 minus 180 power of 2 divided by 180. After the calculation, we can get the answer, which is 7.6363, or we can conclude into the 2 decimal places, which is 7.64. This value represent the total deviation between observed and expected frequency. For the step number 5, we'll continue by my group members. Thank you.
Hi everyone, I'm Shiven. So now I will explain the following step 5, which is to determine the degree of freedom. So this degree of freedom value is very essential. It's because they help us define the critical value against which we compare our chi-square statistic. Okay, meaning in the conclusion part later, it will help us to make a decision whether to accept the null hypothesis or the alternative hypothesis. Right. So to find the degree of freedom, the formula is given, which is k minus 1. So the k represent the number of categories or groups in a goodness of fit test. So now in our case study, we are handling with three groups, which is less than 18, 18 to 35, and then greater than 35. So 3, right? So that is why we subtract 1 from these 3. 3 minus 1, which is equals to 2, right? So this value 2 later will help us to find the critical value in the chi-square distribution table, right? Okay, now we are moving on to step 6, which is to find the critical value. So just now we already find our degree of freedom value, right? So now we are going to refer at our chi-square distribution table. This is where we find our critical value. So in order to find this critical value from this table, we must have two values in hand, which is the degree of freedom, where we already calculated just now. The value is 2, right, just now. And then we are going to look at the alpha that is already given in the question, which is 0.05, right? So referring to the table, the degree of freedom is always in the left column, okay, and then for the alpha value, it is always on the top row. Okay, so that is where, as you can see, from the degree of freedom we choose number 2, and then the top alpha, which is 0.05, that is already given in the question. And from these two values, where it gives us the critical value of 5.991 for our test, right? So then this critical value will be then compared with our calculated chi-square in order to make the conclusion for this test. Okay, now we are moving on to the conclusion part. So this is where we will decide whether to accept the null hypothesis or the alternative hypothesis. So for this, we need two values. First thing is we need the calculated chi-square value, which was 7.6367. we already done in the previous step, right? And then we need another value, which was the critical value, where this value was taken from the chi-square distribution table, which the value was 5.991. So as you can see, this calculated chi-square value is greater than the tabulated value, the critical value 5.991. Okay, so normally when the calculated chi-square value, when they are greater than the tabulated, greater than the critical value, or the tabulated value where we take the value from chi-square distribution table, we will reject the null hypothesis. Okay, which we can also give another meaning, we will accept the alternative hypothesis. So for our case study, since the calculated chi-square value is 7.6367 is greater than the tabulated value 5.991, so we reject the null hypothesis, meaning we are accepting the alternative hypothesis, which means there is a significant difference in the population age distribution between 2015 and 2020 at the 5% significance level. So therefore we can conclude that the age distribution in the population has changed significantly over the last 5 years, right? So that is all. Thank you for my part.
So the next one is case study 2, which is chi-square test for effectiveness of drug. A medical study was conducted with a sample of 200 individuals who were diagnosed with a specific disease. In the study, 100 participants were given a particular drug to treat the disease, while the other 100 participants were not given any treatment. After the treatment period, the results were recorded. Among the 100 individuals who received the drug, 65 were correct and 35 were not correct. On the other hand, among the 100 individuals who did not receive the drug, 55 were correct and 45 were not correct. The goal of the study is to test whether there is any significant difference in the cure rate between the individuals who received the drug and those who did not receive. Specifically, the aim is to determine if the drug had any effect on the recovery rate of the individual with the disease. So here is the data table, which is 100 in the drug group and 100 in the no drug group. The accurate row shows 65 and 55. Where we are testing this specific question in the is the drug effective or not. So to start the step 1, we have to use observed frequency table.
I will be presenting about step 2. Step 2, hypothesis statement. Hypothesis: there is no association between taking a drug and being cured. The drug has no effect. Alternative hypothesis: there is an association between taking a drug and being cured. The drug has an effect. Now we move on to the step 3, which is calculating the expected frequencies. Expected frequency represent the number of observations we will expect if there is no relationship between the treatment and the outcome. Expected frequencies is E equal to row total multiplied by column total divided by grand total. Using this formula, we calculate the expected values for each cell is in the table. From the calculation, we expected number of cured patients using the drug is 60. Expected number of cured patients without the drug is also 60. The expected number of not cured patients using the drug is 40, and the expected number of not cured patients without the drug is also 40. The expected frequencies will be used, and the next step is calculate the C-square statistic. Next, we proceed to the step number 4, which is calculating the C-square statistics. The C-square formula is x power of 2 is equal to observed minus by expected power of 2 and divided by expected. This formula measures the difference between the observed value and the expected value. We substitute the values into the formula for each cells. That what we got is 65 is minus by 60 power of 2 divided by 60 35 minus 40 power of 2 divided by 40, 55 minus 60 power of 2 divided by 60, 45 minus 40 power of 2 divided by 40. After calculating each term and adding them together, we obtain the x power of 2 is equal to 0.4167 plus 0.625 plus 0.4167, I'm sorry, and plus 0.625. This gives the final c-squares value of x power of 2 is equal to 2.0833. The c-squares value will be used in the next step to determine whether the result is statistically significant. That's all from me.
Assalamualaikum. My name is Ahmad Mirzan. So this is about step 5. It's about determine the degree of freedom DF. So in this, the degree of freedom of two recreated table are calculated as. So this is a formula DF from column 1. So in case the degree of freedom is so a ROM is 2 and columns is 1. So the answer is 1. This is for this slide. Okay, this is about step 6. It's about my the iterator value. So it's about using a simulated level of 0.05. Each we can check the derivative value from the cubic square. Derive the table of df1. So this is the greater value of is 0.05 and df1. So it's about so this is for df is 1 in credit square dividers table. So the find 0.05 is from this. The answer is 3.84. So means the answer is the greater value is 3.841. So I have go to the next slide. Thank you. Okay, it's about the last step is step 7. It's about conclusion. So this is about conclusion. That is the greater this reclaim this is 2.0833 is less than the recreated value is in 3.841. We failed to reject the null hypothesis H0. Therefore, we advance the null hypothesis horror, meaning that the drug does not directly impact the curing for the regress. So this is as for me. Thank you.